Kaya, my name is Russell Keith-Magee, and I am here today to show you how to build a cross-platform GUI app using nothing but Python. First off, who am I? I am from Wajak Noongar Boodja, otherwise known as Perth, Western Australia. I'm a member of the CPython core team, and I'm a principal engineer in the open source group at Anaconda. Anaconda pays for me to attend conferences like this one, to talk to people like you, so I'd like to thank them for that support. They also support the Python open source ecosystem more broadly by providing direct financial support to organisations like NumFocus and by employing developers to work full-time on open source projects like Jupyter and Number and the open source project that I founded, BeeWare. For those who haven't come across it before, BeeWare is not a single product or library or tool. It is a collection of open source tools and libraries for creating native user interfaces in Python, for desktop, but also for iOS, for Android, for single-page web apps, and for console. Each tool in the suite solves one specific part of the overall problem of writing a GUI app in Python and distributing that app to other people on various platforms. Anaconda supports BeeWare to ensure that Python remains a viable programming language on the platforms that people are increasingly using as part of their day-to-day computing life, phones, tablets, and so on. However, it's important to note that BeeWare is not an Anaconda product or anything like that. It is a fully open source project with independent governance and funding. I just happen to be paid by Anaconda to work on it full-time. And so, today we're going to be looking at the BeeWare suite of tools and how you can use those tools to write and deploy a GUI application for desktop, for iOS and for Android, all from a single Python code base, and how to access some of the capabilities of the hardware platforms that the features those hardware platforms have. This is going to involve two major pieces of the BeeWare suite. The first is Toga. Toga is BeeWare's cross-platform GUI toolkit. It lets you use a single code base to write a GUI application that can target multiple platforms. And on each of those platforms, you get a native user interface. So on macOS, it looks like a macOS app. On iOS, it looks like an iOS app, and so on. This isn't just a cosmetic appearance either. The apps actually are native. Toga abstracts the native system widgets and capabilities of each platform, providing a common Pythonic API to build GUI applications. This also means you inherit all the native capabilities of those platforms. For example, accessibility affordances like screen readers and adaptive font sizes just work. The second piece of BeeWare we're going to use is Briefcase. Briefcase is a tool for packaging Python applications. It takes your Python code, wraps it up as a standalone unit that you can be given to an end user with no Python experience so that they can install it and run it on their device of choice without them ever knowing that they're running Python code. In our case, we're going to use Briefcase to prepare an iOS and Android app that could be submitted to those platforms' respective app stores. Now, while Briefcase obviously pairs well with Toga, Briefcase isn't BeeWare or Toga specific. You can use Briefcase to deploy a Pygame app if you wanted to. Briefcase can't magically make Pygame work on iOS, but to the extent that a GUI library supports any given platform, Toga can generally support deploying that GUI framework onto that platform. All right. So let's dive right in. Let's write an app and then deploy it across multiple platforms. We'll start with something fairly simple, text inputs, buttons, dialogues, but then we'll add more features as we go. So where do we start? Well, Briefcase has a wizard that you can use to bootstrap a new application. So we create a new virtual environment, we install Briefcase, pip install Briefcase. With Briefcase installed, you can then run the wizard to start the project. You run Briefcase new, you'll be presented with a list of questions with explanatory text. You get asked for questions like your project name, your email, license details, preferred GUI framework, and so on. We're going to create an app called PYCON Demo. We're then going to use Toga for this example, but there are also templates for other GUI frameworks like PySide and Pursuit PyBear. There are third-party toolkits like Pygame CE that actually provide a Briefcase plugin, or you can select a completely empty project with no GUI framework at all. When you complete the wizard, Briefcase generates an app and will then give you instructions on how to run the project. So let's follow those instructions. cd PyCon demo and run Briefcase dev. Briefcase includes a developer mode, which lets you rapidly iterate on your app and its configuration. When you run Briefcase dev, Briefcase looks at the project configuration, works out how to run your project in your local environment. The first time you do this, it'll install some dependencies based upon whatever your template generated, and it'll start your app. For what it's worth, Briefcase dev is really not much more than a convenient shorthand for a bunch of pip installs followed by Python -m PyCon demo with a couple of debug flags and other environment pieces set up. If all you've got is the content that's been generated by the wizard, at this point what you'll see is a working app. It'll be an empty window, but it will be a working GUI app. So what has the wizard generated for us? Well, if you look in the PyCon demo folder that's been generated, you'll find all the code for your app, application icons in a variety of formats, and project metadata. You'll get the same files regardless of what GUI framework you pick. The only difference will be the contents of the app.py, the main.py, and some of the values in the pyproject.toml and readme files and the license file. The pyproject.toml will contain the literal answers you've just provided in the wizard with some values that can be guessed, things like an initial version number, plus some additional platform-specific configuration that will be implied by your answers. So if you've selected Toga as your GUI toolkit, you'll get the requirements and other configurations necessary to support a Toga app. All of the Briefcase options are defined in the tool.briefcase sections and subsections of the config file. Some PEP621 format metadata is on it as well. That's the project configuration. What about the app itself? Well, the logic for the app is all contained in app.py. At the moment, it's a bare stub. It declares a class called PyCon demo, which is a subclass of toga.app. That class has a startup method. That method creates a box. That's Toga's representation of a generic container of content. It creates a main window and then sets the content of the main window to be our box of content. And then it shows the main window. The main method for the app creates an instance of that app class. That's all the code we need to generate the empty app window that we saw before. So now let's replace our startup method with some code that actually does something. In our startup method, we're going to define a static text label with the text your name. Toga lets you set the style of each widget using a subset of CSS called pack. So we tell Toga that we want this widget to have a margin around its outside. Then we define a text input so we can get some information from the user. Again, we give it some style and we mark the text input as flexible. Toga's layout, again, is based upon CSS3's flexbox. So marking a text input widget as flexible means it will expand to absorb any available space. You'll also note that we've attached the text input widget as an attribute of self, so as an attribute of the app. That's how we can access the widget later. We don't need to do that for the label because it's just static text, but we could have if we wanted to, and there are other ways to retrieve a widget from a running app. We then create a box, again, the basic container widget in Toga, and tell it that it's going to have two children, the label and the text input, and indicate that it should be a row box. So all of its children will be stacked horizontally with a margin around each element. Next, we define a button and with a label of say hello and a margin and declare that when the button is pressed, we want to invoke the say hello handler on the app. That's all the widgets we need for now, so we can define our app's main box. This time we're saying the main box is a column box, so all of its children are stacked vertically. And this time, instead of declaring the children at time of construction, we're adding them one by one. It's functionally identical to what we did with the name box, so what we now have is a main box where all of its children are stacked vertically. The first child in that main box is a horizontal box containing a label and a text input, and underneath that is a button. At this point, we can then pick up where the old code left off, create a main window, set the content of the main window to be our main box, and then show that main window. There's one piece of housekeeping we have to attend to. We said that when the button is pressed, we want to invoke the say hello handler on the app, so we'd better declare that handler. When say hello is invoked, the first argument is the widget that generated the event, in our case, the button. There's only one button, so having the widget in this case doesn't really help, but if we had multiple widgets, we could attach them all to the same handler. It might be useful. What happens when the button is pressed? Well, we want to show a dialog to the user. So the dialog will ask for the name text input for its current value, and then use that value as the title of the dialog. You might have noticed here that this is an asynchronous handler. Toga will let you use any function or coroutine as an event handler, and Toga fully integrates Python's async IO event loop with the native platform async IO event loops that are used by GUI frameworks. Why would you want to use an asynchronous handler? Well, no matter the GUI framework, no matter the platform, a GUI app basically boils down to a loop. That loop is essentially while not quit, process events, then redraw. Now, this is pseudocode, not a literal API anywhere, but honestly, it's not that far from reality on most platforms. Every time you click on a button or type a character or drag the corner of a window to resize it, that's an event in the GUI system. And the app code will respond to each of those events in turn, causing changes in the state of the app. Those changes in state are then reflected in the appearance of the app the next time it's redrawn. The important detail here is that when the app is redrawing, it's not processing events. And when it's processing events, it's not redrawing. If you've ever seen an app beach ball or show a little spinner icon that looks like it's processing and it's not doing anything, this is what's happening. Your app is trying to process an event and it's taking too long for whatever measure of too long your operating system's defined. So it hasn't redrawn for a while, And so the operating system warns you there's a problem by showing you a beach ball. So, going back to our event handler, we want to show the user a dialog, but then we want to wait until the dialog has been acknowledged. If the handler was a synchronous method, while you were waiting for the user to respond to the dialog, the app wouldn't be processing any other events or redrawing. Depending upon the platform, that might even include drawing the dialog itself. By using a coroutine and awaiting the result of the dialog, we can pass control back to the event loop until the user presses the OK button on the dialog. All right, so that's all the code we need for a simple GUI app that will show a dialog when the user presses a button. So let's run it. We rerun Briefcase dev, we can start the app again, and this time you'll see an app with a label, a text box and a button. The text box is flexible, so it expands to fill the available width. Buttons are flexible by default, so it does as well. Type in a name, press the button, and you'll get a dialog, whatever text is in the text input when you press the button. All right, so we've got our app running in development mode on our laptop. Let's run it as a full app. The next step is to create your app. To do this, you run Briefcase create. This does a bunch of things. First, it will look at the platform you're currently on, get an application template for that platform. So if I'm running on macOS, it'll use a macOS app template. Secondly, it obtains a support package. A support package is a version of Python that can be embedded into your app. Whatever your platform, Briefcase will download a support package, unpack it into the application template that was just created. Then Briefcase downloads and installs a stub binary, a literal executable that can be used to start your app. Think of this as a copy of python.exe that's been hard-coded to just start your application. You need to do this so that the app appears in your operating system's task manager as PyCon demo, not python.exe. Then Briefcase installs your application code, anything declared in your sources section of your project. It then downloads and installs your app's requirements, but it doesn't install them into your local virtual environment. It installs them into the application template. You're building an application for distribution, so you can't rely upon anything that's in your local virtual environment because your end user won't have access to that environment. Then Briefcase installs any application resources like icons, purges any content that isn't needed, and it's done. You've now got a complete application template. The next step is to build the app with Briefcase build. What happens in this step varies from platform to platform. On macOS, it needs to sign the application binary. On Windows, it needs to write some app metadata. On Linux, it actually needs to compile the stub app. And at this point, there'll be a subfolder of the build folder that will contain an application along with any files created as part of the build process. In this case, it's a macOS app. If you were to click on that icon, the app would start. Or you can keep it all in console-based and just use Briefcase. Run your app with Briefcase run. And what you'll see is a running app. It will be almost identical to what you saw with Briefcase dev, but with a couple of distinct differences. The app will present to the operating system with your app's formal name, so PyCon demo in this case rather than Python. It will also have the application icon in the toolbar. Depending upon your platform, there could be some other subtle differences as well. All right, that's desktop deployment. What about deploying to a mobile platform? Well, the steps are exactly the same. You just add iOS or Android to all of the commands, and you're done. Briefcase create iOS, Briefcase build iOS, and so on. Same for Android. iOS builds will only work on macOS because of the underlying tooling requirements, but Android builds can work on macOS, Linux, or Windows. When you build Briefcase run iOS, Briefcase will ask where you want to run the code. It'll look for simulators that are available on your system, provide a list to choose from. If you want to shortcut that question, you can specify -D and give a device ID or a device description. On Android, it'll also walk you through the process of creating an emulator image if you need one. But once you've picked a device, the app will start, and you'll see a mobile app that has the same layout as the desktop version, just running on your a device emulator. Type some text, press a button, you'll get dialogues. Briefcase can currently only target iOS simulators. Briefcase will manage the process of starting the simulator, launching the app on the simulator, tailing the log so you can see the app run. You can deploy on physical devices, but you need to use Briefcase Open to open the Xcode project that Briefcase generates, sign up for an Apple developer account, and then set your developer credentials in the Xcode project. On Android, you can target emulators or attached devices. You do need to do a little bit of a dance with a physical device to put it into developer mode, but Briefcase will guide you through that process. Briefcase can also target single-page web apps. Same process, Briefcase create web, Briefcase build web. Briefcase will generate a bunch of static web content that you could upload to any web server. Briefcase run web will then start a local web server, open a browser, point the browser at that server, and you'll see your app rendered as a single-page web app. Type a name, click a button, you'll get a dialog. This is a static single-page website. All the app logic is executing in the browser, not going back to the server. All the server is doing is delivering the content to the browser. It's using PyScript to embed a full Python interpreter in your browser, and your app's code is running in the browser. You press the button, the logic to open the dialog is entirely client-side. And it's also possible to run this demo in the console as well. This is a Toga backend implemented using textual. It's a little messy to set up at present, but it is possible, it does work. Toga's web and console backends are the backends that need the most work at present. They're enough to run this demo and a little bit more, but they need a lot more work to be at parity with desktop and mobile platforms. So if you're looking for an open source project to contribute to, just saying. Having validated that our application works, we can now package it for distribution. Invoke Briefcase package, and Briefcase will do any final packaging needed to produce a single artifact that you can use to give to somebody else. What is involved varies depending upon the platform. On Windows, it will create an MSI installer. On Linux, it creates an RPM deb package. On macOS, it'll create a DMG, signing and notarizing the results. Some other features of Briefcase that are worthy of note. Although I've used the wizard to bootstrap this project, you don't have to use the wizard. You can manually write your PyProject.toml Briefcase configuration from scratch, or if you've got an existing project with the PyProject.toml, Briefcase convert can be used to add a Briefcase configuration to that pre-existing project. If you're on Linux, you can also target distributions, different distributions using Docker. Provide a -- target option with a Docker base image when building and packaging your app. Briefcase will use Docker to build a deb package when you're running natively on Fedora. You can even use Docker to test the app and export the display out through X Windows. Briefcase will imply earlier steps if they're needed. If you have a fresh project straight out of Briefcase new and you invoke Briefcase run, Briefcase will detect there isn't a template yet, create it, build it, and then run it. Briefcase open will open your project. It's a simple project. If it's a simple project like a macOS app, it'll just open your file manager in the build folder for the project. If it's an IDE-based project, it'll open the IDE on that project. If it's a Docker build, it will open a shell session in the Docker container that was used to build the app. Okay, so we've got a working cross-platform GUI app. Let's add some more features. What are we going to add? Well, mobile devices have GPS readers and they're great at displaying maps. So let's add a map and a GPS read to our application. Since we want to add some additional features and not replace the features that we already have, we're going to need some way to navigate about our app. So let's add a tab widget so that we can switch between pages of content on the home page of our app. So previously, we created our main box and set that as the content of our app's main window. Let's modify that a little bit. We'll create an option container widget. It creates 2 pages of content, one labeled dialog and one labeled map. Then we'll set the main window's content to be the container rather than the main box. We'll use the existing main box content on the dialog tab. The second tab of content is going to use a map box, which we now need to define. What's in the map box? Well, 2 things. A map, set as flexible, so it will expand to fill the available space, and a button we can press to update our location. So there will be an event handler when the button is pressed. Put both of those in the map box. That's our layout done. We can now define our event handler for when the button is pressed. So whenever the button is pressed, let's get the current location, zoom the map to that location. Location services are governed by platform permissions, so we can't just get the location. We need to make sure that we have permission first. So we request permissions from the app's location service. The location service is a hardware feature that Toga has wrapped with a cross-platform API. There's also a camera service. We'd like to add other things like accelerometers, any other sensors that are common on phones. Asking for permissions, we'll check if the user has previously granted permissions to the app. If they have, then that'll be a no-op. If they haven't, a dialog requesting permission will be displayed. If the user has previously rejected permissions or they reject permissions this time round, the request will fail and raise an exception. But if it succeeds, we can ask the location service for a once-off ping. That'll return a location, which we can then use to set the center of the map, changing the zoom level while we're at it. We could also turn on continuous location tracking, or we could drop a map pin. Toga provides APIs for those as well. There's another exception that could be raised here, not implemented. Toga has a map view on all desktop and mobile platforms, but it doesn't currently have a GPS read on Windows. So if you know how to do GPS reading on Windows, get in touch. There's 2 other changes we need to make, this time to the project configuration. We can't just ask for permissions, we need to declare that we might ask for permissions. Briefcase has a cross-platform representation for common permissions related to location services, camera access, microphone access, a couple of others. But there's also a mechanism for adding platform-specific permissions if you need to. In this case, we're asking for permission to know both the coarse and fine-grained location. Not all platforms differentiate between the 2, but Briefcase will let you specify both and interpret those values as needed on the platforms as it supports. The values provided for these permissions are the text that might be displayed to the user to explain why location access is required. The text that I've used here is not a good example. On macOS and iOS, for example, this text will be used as part of the app approval process, and your app might be rejected from the App Store if it's not sufficiently illuminating in the eyes of an Apple reviewer. One last change. On macOS and iOS, map view is available natively, but on Android, we need to add a third-party Android package for OpenStreetMap. This is added as a Gradle dependency. Android build process will manage downloading the Maven package in the same way that pip would download a PyPI package. So we need to add the OSM Droid line to our Android configuration. On Linux, there are also system dependencies that need to be added. They vary between distributions. Now, because we've changed permissions and we've added a binary dependency on Android, we need to regenerate the app. This is also a side effect of how Briefcase works. The files that need to be modified to add permissions. When you only change the code of an app or just add a dependency, Briefcase has an update command. However, when you change permissions or system dependencies, those properties are defined in core project metadata that is populated when the app is created. By adding permissions and system dependencies, we need to update those files, and at present, Briefcase can't update existing core project metadata files in situ. That's something we'd like to fix. We've got some ideas how it could be done. However, while recreating the app might seem a little confusing and maybe a little inconvenient, it doesn't actually impact anything in practice. You should be considering your Briefcase build folder to be an ephemeral artifact. It could be and will be deleted at any time and replaced with an updated version. You shouldn't be manually modifying files in your build folder. Your version control system shouldn't be storing any artifacts in your build folder. And the CI process you use to release your app should be starting with a fresh build every time. When you do run create and there's an existing build, you'll be prompted to confirm you want to delete the old project, so you are protected against mistakes and inadvertent deletion. And so, when the app runs, with a second tab containing a map, we can press the update the location button. You'll get asked for permissions, approve permission, and the map will zoom to an updated location. We're on a simulator here, so the behavior is a simulated GPS read, so the results are slightly different. But if you were on a phone, it would give you a physical location. I have an example here if anybody wants to see it. And so, a quick recap of what we've done over the last 20 minutes. We have created a new application. We have run that application in developer mode, allowing us to rapidly iterate on the development of an app's display. We've added some basic input widgets like buttons and text inputs. We've displayed the results in dialogues. We've added tab-based navigation between panels of content. We've added a map. We've integrated our phone's geolocation services to control the display of that map, including requesting permissions required to access geolocation services. And all of this has been done entirely in Python, using Python tooling and configuration files, producing an application that is completely native and entirely self-contained. Although I am a Python developer, the apps that I've generated could be uploaded to an app store or distributed on a website, and the only instructions end users would need would be download and click to start. And the resulting app would be indistinguishable from an app built with Swift on iOS or with Kotlin on Android or C# on Windows. And yes, there are BeeWare apps in both the iOS and Android app stores. All right. So, what does the future hold for BeeWare? Well, my co-worker Malcolm and I are currently working on the tools for building iOS and Android wheels. As of today, PyPI will accept the upload of iOS and Android binary wheels. Pip and UV will both accept iOS and Android platform tags as inputs. CI build wheel has support for targeting iOS and Android. So it is possible to do pip install NumPy and use NumPy on your phone. Malcolm and I will be working with some other high-profile packages to land iOS and Android support over the rest of this year. Check beeware.org/mobile wheels to see which popular projects have iOS and Android wheels today. We'd also like to go further with the assistance Briefcase provides with packaging applications, including packaging or deployment to physical iOS devices, adding publication to app stores as a smoother process as well. And lastly, there are platforms that BeeWare doesn't currently support. Apple and Android watches, tvOS set-top boxes, VR headsets. I want to get Python everywhere. So, that's cross-platform GUI development with BeeWare. If you do nothing else, I recommend going through the BeeWare tutorial, tutorial.beeware.org. That gives you a more complete walkthrough of the stuff that I've spoken about today, plus a whole lot more. Briefcase has plenty of configuration options and other details I haven't gone into, though. If you want to know more, Briefcase's documentation is very thorough. And I've only touched the very surface of features in Toga. Toga's documentation has a lot more details, and the Toga GitHub repository has a lot of example code as well. If you like what you've seen here, you'd like to support BeeWare as a project, you can join the project as a financial member. You can also back me on GitHub sponsors. The income we use is used to cover stickers and hosting and things like that. Like I said earlier, I am paid by Anaconda to work on BeeWare, but the project itself is independently managed and funded, so this financial support is important. Or if working kind is more your thing, we're always looking for new contributors. We have challenge coins for people who contribute. Come have a chat if you're interested. I will be at the sprints tomorrow if you want to get involved. We've also got a Discord plus discussion forums and ticket trackers for all the projects. Details on the website, beeware.org. Thank you all very much.
Sadly, there's no time for questions, but Russell, I'm sure, will take them in the